Hey, this is Travis again with another quick code video for learners of Python who maybe are adult learners like me, or they're adolescent learners and they're struggling with some of these foundational concepts. The point of these quick code videos is to keep it really short, like ideally 6 minutes or less, maybe 8 minutes, but it's not a C# dev diary. I'm kind of doing these in between because, as I said in the first quick code video, I'm working with a couple different adult learning networks of people like me who are trying to learn programming for whatever reason. My use case is that I want to make teaching apps for teachers. I am a teacher, I'm a coach, and I want to be able to make better tools to help my colleagues do some of the mathematical elements of our jobs more easily, or to utilize that data in a faster, more efficient fashion. And that's what I've been learning in C#, but I'm still working with Python. I'm still coordinating with people who are learning Python, and some of these concepts have come up, and I wanted to make quick videos so that they can reference them, because sometimes it takes a different teacher. So a while loop is like the for loop that I did in the last video, and what it does is it basically says, while this condition evaluates to true, then I want you to continue to do something. I want you to continue to loop. So for example, if I pull out my cards from before, while there are still cards in the deck, I want you to continue to execute code. The while loop doesn't care about the contents of the cards. It just cares that this condition, are there cards in the deck, that is true. So there are a couple different components to writing a while loop out that we need to be very aware of in Python. First of all, we have our while keyword. Let me blow this up a little bit more so we can see it. Then we have an expression. An expression in code is something that can be evaluated and executed, or executed, evaluated or executed. Python, unlike C#, which is where most of my focus is, does not require you to put your evaluative expression into parentheses. So it can get a little bit lost in there. You might not be able to see it if you don't know what to look for. But in Python, we would just say while pencil is exactly equal to yellow, the string yellow. Now notice this isn't just equals to, because the equal sign in Python and in C# is an assignment operator, but while it is exactly equal to. Is IntelliSense going to give me a definition there? No, it's not. Okay, so this is how you say is equal to. You need the double equal sign comparison operator. You could do while it's not equal to. You could do, well, it wouldn't make sense here because we're using strings, but less than or equal to yellow. Those are your different assignment operators. For this particular while loop, while the pencil color is equal to yellow, then it should ask me what color is the pencil. So the way that this quick little program is written, I start by defining the pencil color as yellow. So it starts off, the memory remembers, okay, the pencil color is the string yellow. And then I'm going to print off a very quick thing telling the reader this is the current status of pencil color. The pencil color is yellow, and then I enter, because code executes from top to bottom, left to right, we move down to the next thing. It's a while loop. While that pencil color is exactly equal to yellow, then pencil color's variable can be assigned to a new input, which I prompt the user to say, what color is the pencil? So take a second here and just think about what happens if I input. My goodness, I have a master's degree in literacy. What happens if I input yellow? Well, what should happen is it's going to finish this execution, and then it's going to loop back. It's going to go, okay, is this still true? The pencil color is exactly equal to yellow. Yes, it will. So it's going to then say, okay, what color is the pencil? What happens if I input green? Well, let's find out. So I'm going to run this program. So down here on the, oh, it's actually a little bit too low for you to see. Let me move myself. Whee! Little field trip there. All right, so what color is the pencil? I'm going to input yellow first of all to see what happens. And there it is. It's looping. It'll do this ad infinitum as many times as I want. But eventually, maybe I get sick of yellow pencils, right? And I input green. What happens? Well, if we go back to the code, it reports the pencil is now green, goodbye, and then it terminates the program. if I go back to my code, the last line here is, let me push it up, printing a F or a format string, the pencil is now, and then it reports back to pencil color. Well, it reported that it was green, right? That's because in the while loop, I overwrote the pencil color to be green. So when it loops back to reevaluate, the while pencil color is exactly equal to green. That's no longer true. And here's the important thing. If that expression in the while loop does not evaluate to true, it skips the loop. It goes right over it. It does not execute what's within it. So you're really looking at while true or while false. Whatever is inside these invisible parentheses needs to evaluate to true or false. And that's actually pretty common with running software or running a game loop, is having something like while true or while running is exactly equal to true, something like that, where we'd have a running bool up here as true. If it's like this, when the code hits this section, while running equals true, it will then execute the loop. But if I set this to false, it won't run the loop at all. Watch. That's it. It goes pencil is yellow, okay, cool, running is false, it skips over the loop, and then it's done. So I have another example here. Let me close the terminal, and this is close to my heart, but Bills Super Bowl wins are equal to 0. Here's something that we need to be aware, and I know I'm already getting kind of close to my 8-minute mark, but we do need to be aware of infinite loops with while loops in particular, because if there's not a way to meet the condition to break out of the loop, you will get stuck infinitely, right? And that's our boys in blue here, the Bills. While Bills Super Bowl wins is less than or equal to 0, which it is, right? Remember, this is parenthetical here, so this needs to evaluate to true or false. Then it will print next year's our year, boys. If I run this program, it's just going to do this infinitely. I'm going to stop it real quick. You can just see scrolling up over here. Look at how many years it has not been our years, boys, right? So that's an infinite loop. We need a way to break out of it. So I'm going to comment this out, and I'm going to open up this other one that I wrote, which, let me give you some more space. So we still have the Bills Super Bowl wins is equal to 0, but I also have this other variable, pit sacrifices, that if you watched last season, you might be aware of some of the goofball shenanigans with the new Bills Stadium. But while Bills Super Bowl sacrifices, while Bills Super Bowl wins is less than 0, less than or equal to 0, we're going to increment the pit sacrifices by 1. And we'll print, just to be thorough, we'll print pit sacrifices. And if pit sacrifices is greater than 99, so if pit sacrifices hits 100, then we win a Super Bowl, right? That's definitely how this works. And it'll print the Bills finally won. But the question here is, what happens once the Bills Super Bowl wins goes up to 1? Really what we're asking is the while loop here. So let's run this quick program in the terminal and see what happens. Because we want to know, can we get to, they finally did it. Can we get to that? Without this line, we're going to run into some problems. So let's comment that out real quick and see what happens. 0, right? I'm reporting the pit sacrifices. It's not going up by 1. Notice it has not incremented over. But if I open this line up and I start changing what this value is, it will allow the code to access this condition now. And we'll rerun it. It's going up, and it's maybe a little bit hard to see. We're going to banish me to the upper left corner again. And now at 100, remember 100 pit sacrifices, the Bills finally win their Super Bowl, and we're able to access that line beyond and after the while loop that says they finally did it. So with a while loop, you've got to be very aware. Wow, I really went on an adventure there. You've got to really be aware of what your breakout condition is and have a means to escape the while loop so that you don't end up in that infinite loop forever and ever. So you might need something like an incrementer that will allow it to take over, or you need a break keyword, which I'm not going to cover right now because I feel like it's simple enough. But if you think you want a break keyword quick code video, I can throw one together for you because it's pretty useful. So that's it. We've got a while loop. We've got an if in there. We've got an evaluatable condition. We've got some printing so that we can check to make sure that our code is actually doing what we think it's doing. And we've got a little bit of sense of humor here. So that's it. That's the while loop. They go hand in hand with the for loops. You often find them working together, and you want to be confident when you need to use them and not intimidated by them. So while you like this video, maybe consider hitting the subscribe button or something. If not, break.